we're not really going to go through anything like alarmingly new. We're just going to talk about, now that we know how to solve logarithmic and exponential equations, how can that help us with things that maybe are in more of a realistic realm, okay? Yet Monday I gave you problems like, here, solve this problem. Now let's talk about some applications and what we can do with it, okay?
I believe Richard's in your class.
She is. All right, so let's first talk about our two interest equations. So we have compound interest and we have interest that is, or we have continuous compound interest and we have interest that's compounded so many times per year. Okay, so you already have this in front of you. How long will it take an investment of $1,000 to double if your investment rate is $8,000 and the interest is compounded quarterly? So just take a moment and write down in that equation all of the things that you know. Okay, so our $1,000, that's what we're starting with. That's our principal amount, okay? Remember our rate, is 8%, so we changed it to 0.08, and quarterly means that N is 4. Quarterly is 4 times a year. So we have $1,000 times 1 plus our rate over N, all to the NT. Okay? And if we want this to double, what's our amount? 2,000. Okay? So now we're just solving for t, and t is in the exponent, right? Do we know how to solve an equation where the variable's in the exponent? Okay, so let's talk about this. What should our first step be? Divide the 1,000 over. Okay. All right. And let's go ahead. 1 plus 0.08 divided by 4. Does that give us a nice number? 1.02. Okay. So now we have our our base to the power isolated. So we can change forms. Log base 1.02 of 2 equals 4t. Please calculate how many years this is going to take. Austin, how long is it going to take?
I don't know, because I got 0.004.
That doesn't seem right, does it? Okay. So, instead of punching that in up there, go to math. Okay, so what was that new one now?
8.751.
Okay, 8.751, and what would our label be? Years. Okay, that was a common mistake on the quiz. Time is always in years. Make sure you convert it if it's not. Yes.
Do you want us to round to 3?
We can do 3. 3 is fine. I'm not gonna. If I don't say specifically, I'm gonna probably be flexible with the other one. All right, let's talk about continuously. If we see compound continuously, we think of everybody. With so much enthusiasm. Okay, so we know that our principal is 1,000 E to the RT, and we want it to double. So we want our amount to be $2,000. Do you think it's a coincidence that when we divide this principal amount over, we get 2? Do you think that's a coincidence? No. You don't even have to know the amount that you start with. If you want it to double, you know that amount divided by principal will be 2. If you want it to triple, you know that amount divided by principal would be 3. Okay. Go ahead and solve this one out for me. Will it be quicker or longer? Should be quicker. Compounding continuously should rack up interest faster. So we should get it. We should double sooner. Callie, what do you have for me? 8.664 years. Okay. So now I've basically introduced you to, last week we talked about interest. Well, now I can either give you information to find the amount, or I can give you information for you to find the time it takes. Okay, we can solve them either way. And you would need to be prepared for either. Okay. All right, so let's talk about some exponential growth and exponential decay. There at the very bottom of your first page, you have 3 graphs. Okay, here is a model of exponential growth. Okay, and we've really talked about exponential growth, but we haven't talked about it in the form of like being an application problem. So you have this right here. Y equals A e to the bx. Okay? What is that going to represent in some sort of application problem? What does it represent in PERT? The rate. Okay, so I know this isn't PERT because we're not talking about like, we're talking like in a general sense, but that's going to represent your rate. Okay? What about this number right here? Okay, so in PERT it represented principal. We can, in a general sense, say that this is our initial amount. Okay? If we plug in 0 for x, e to the 0 is 1. We're left with that a value. So a is going to represent how much we start with, whether it's money or not. Okay. Exponential growth, we're going to have a positive rate. Exponential decay, we're going to have a negative rate. Okay? How many of you talked about exponential growth and decay in science class? Okay, would that be chemistry? Okay. Physical science, maybe? You can take chemistry and not have to take physical science, right? No, you have to take physical science? Could you take, like, chemistry and then physics and not have to take physical science?
Yeah.
Okay. Got it. All right, this is a new one. All right. This is called logistic growth. Okay. This is something that I focus on in my Calc 2 class and like the calculus of it. But you'll see this with like the spreading of rumors. So if you spread a rumor, it spreads really quick, and then it still spreads, but it just doesn't spread as fast. So you kind of see in this graph, like it spreads really quick, and then it kind of tapers off. And you have what's called a carrying capacity. It can only reach a certain limit. You'll also see this like with the spread of diseases. Like they'll spread really quick, and then they'll still spread, but then kind of taper off. Okay. So I think we'll look at we'll look at a virus example here on the back. So we have two examples that we need to get through. Go ahead and turn over to the back side of your paper. Okay. Go ahead and read through that fruit fly one. If any of you are interested in maybe more like biology research, fruit flies is a very common like first step into research. Like if you go to college and major in like some sort of biology, there's a pretty good chance you'll have to work with fruit flies for like some sort of data collection. Okay, my roommate in college did it. It was very strange. Like there's those little itty bitty, but they die really quickly. Okay, there's a reason I didn't go into science. So what do we know? After 2 days, there's 100 flies. After 4 days, there are 300 flies. How many flies will there be after 5 days? Okay, so we know that we have exponential growth. Okay. Okay. We know that after 2 days, there are 100 flies. So do we know the initial amount? No, and what else don't we know? We don't know the rate at which they're growing, right? Those are the two things we would need to know in order to be able to plug into this equation. What is A? What is B? Okay? But we know that after 100 days, after 2 days, there are 100 flies. So when we plug in 2, our output is 100. We also know that after 4 days, there are 300 flies. So when our input is 4, our output is 300. We need to figure out A and B so we can determine what our model is and plug values into it. Okay? Now, it would be nice if they said we started out with this many flies, but they didn't. Okay? If they gave us the initial amount, we would have A right down. But they didn't, and that's okay. We have 2 equations, 2 unknowns. We've solved things like that before, right? Yep. Okay? Now, when you think back to systems of equations, you think back to like substitution and elimination. Okay? Elimination is not going to be our friend in this case. We're going to want to make a substitution. Okay? So this is what we can do. There's an A in this equation right here, right? Okay. So we can go over here to this equation and rewrite it as A equals 100 over e to the 2b. Right? Is that allowed? I can just rearrange it, right? Well, if this is A, we can go ahead and plug it in over here. Do you agree? So 300 equals A, I'm now going to write as 100 over e to the 2b times e to the 4b. this fraction is being multiplied right here, right? I have e to the 4b, and we're dividing by e to the 2b. Can I squish them together? We just an e to a power. We have the 100. This is like e to the 4b over 1, right? So if we have e to the 4b, and we're dividing by e to the 2b, what do we do with exponents when we divide? We subtract. What's 4b minus 2b? Okay. Well, this is looking a little nicer, isn't it? We can divide that 100 over. E to the 2b equals 3. At this point, we've isolated our base to a power, so what can we do? We can rewrite. Okay. Max, read me what your rate is out to 6 decimal places.
Oh, 6.
Mhm.
I had 0.549306.
549306?
Yeah.
Why would I say 6 decimal places? Well, okay. Am I going to have to use this number again? Yes. And if we're going to round again later, we probably want a few more decimal places. That way we have accuracy later on. And it's a rate, okay? If I'm going to take a rate and round it, we want to round off, you know, we want more decimal places, okay? Because it's such a small number. Okay? Well, if B is 0.549306, can I now figure out what A is? Yeah. Go back up to here. Okay. A is 100 over e to the 2b. Can I show you a trick on your calculator? You had to take the natural log of 3 divided by 2. Okay. And now we're having to take, what are we taking? 100. We're having to take 100 divided by e to the 2b. Watch this. 100 divided by, in parentheses, well, I guess we wouldn't need parentheses. E to the 2, this is my number B, right? Watch. Second answer brings up the answer from before. So instead of having to type that number again, I can say second answer. Boom, there it is. Or you could say 100 divided by E to the 2. Those of you with 84s can arrow up, highlight it. Ooh, I should probably hit that. And bring it up that way. Isn't that cool? Okay. Just so you don't have to work harder with your calculator. All right. So A is 33.333. Have we answered the question? Here's our model. here is our model. Y equals A e to the bx. A is the number of flies you start with. Now, do you think they really started with 33.3 flies? No, but data is never exact, right? We're just fitting a curve to the data points that we have, and we're using it to predict the future, okay? Your data is not going to be perfect, okay? But we fit a curve to the data points we know. And we know the rate at which they're growing. So now, if we want to know how many flies there are after 5 days, where do we put the 5? It's our input. We put the 5 into X. How many flies do we have? Huh? Point what? Okay, for now, okay, we can keep it. I would not round to 520 because we don't have 520 flies yet. We for sure have 519 flies. Okay, but if you give me a decimal, it's okay. I will be flexible with that. I'm not going to make a big scheme of that. Okay. All right, what do you think? Okay. Now, if they gave us the initial amount, would we have had to go through all of this? No. If they gave us the initial amount, all we would have had to find was B, not A and B. So if they give you an initial amount, you should be like, woohoo, because your work just got cut in half. Okay. All right. Go ahead and read through the last example. Okay, this model right here, it's not exponential growth. What does it look like? That weird one, right? The logistic growth, okay? It's one of those ones that's going to grow really fast, but then it's going to taper off, but continue to grow, okay? So, how many students are infected after 5 days? Well, if Y equals 5,000 divided by 1 plus 4999 e to the negative 0.8t. What do we want to do after 5 days? What do we do with 5? Plug in for Y? Plug in for T? Okay. Now, please be smart with your calculator. Okay, I can plug that in all at once. I can plug in 5,000. Here, 5,000 divided by parentheses because we have a quantity. 1 plus 4,999 e to the 0.08 or 0.8. Negative 0.8 times 5. Look at that. All in one swoop. Oh. negative 0.8 times 5. There we go. 54?
Yeah.
54.09. 02? I don't know what I was reading. Okay. So 54 students are infected. Okay. 54 students are infected. All right. Now, after how many days will the college cancel class? Well, how many students are on campus? 5,000. Okay. How did you know that? Oh, it set it up here. Dang it. Okay. I was like, ooh, you guys know that. That's okay. 40% of 5,000 is how many students? Dallas, how'd you get that?
How did I get 2,000?
Yep.
Oh, I get 5,000 times
5,000 times 0.4. Thank you. This is what we're going to have to solve. We need to solve for t. We have to bring our patience. All right. Thoughts on what to do first? Multiply that denominator over. So we have 2,000 times 1 plus 4,999 e to the negative 0.8 t equals 5,000. Oh, we can divide over that 2,000 now, right? Now what? We can subtract the 1. Is anyone tired of writing 4,999? Yes. Now, here's where this gets a little, I don't want to say tricky because that's not the word. You need to just be very careful. You're probably going to put that in your calculator, right? Okay, I would if I were you. But please do not round in your work. Do not round in your work. If you round to 3 decimal places here, and then we round to 3 decimal places again, and then we round to 3 decimal places at the end for our answer, you're not going to be accurate. So what I would do is, that's 1.5. Oh, oops. 1.5 4,999. Okay. So a really small number, right? Okay. Well, we know that we are going to have to change forms, right? Log base e of 1.5, whatever, equals negative 0.8 t. All right? Well, if that is what we have, we know we need to take the natural log of that number we just found, and then to get t by itself, we need to divide by that negative 0.8. So in our calculator, I'm going to punch natural log of the answer that I just got, and then we're going to divide by the negative 0.8. On the 10th day, they're going to have to say, no more classes. Now, I have heard of this happening very rarely. I've never experienced it, but there have been situations where if enough people get sick in a school, they have to cancel classes. I've heard of that happening during cold and flu season in little small towns where a lot of kids get sick. But
never experienced. So,
Okay. So you have the homework assignment for tonight on your gold sheet says Tuesday. It's the last homework assignment you have from the book. Okay, it's with 3.5, which is on your notes. Hopefully that's kind of a clue there for you. Tomorrow we'll go over the homework, like I said. You'll have a short little quiz just so you can kind of get an idea of your understanding. And then we'll get into the review.